Thank you for visiting Optimal Anesthesia. Why does remifentanil cause ester hydrolysis? We'll dissect this fascinating medicinal phenomena so you can follow along. Get your brains ready, because we're about to get down to business. Let's start with a definition of ester hydrolysis. The breakdown of an ester bond is at the heart of this process. The chemical structures of certain medications have a form of bond called an ester bond. Remifentanil, a strong opioid used to treat pain during surgical operations, is the topic of today's discussion. It is a member of the phenylpiperidine class of opioids. However, the molecular nature of remifentanil sets it apart. It has an ester linkage in its molecular structure. Remifentanil is distinguished from other opioids, such as fentanyl, by virtue of its ester linkage. Imagine a little bridge connecting different regions of the molecule. This is when things start to get exciting. Esterases are a class of enzymes found in living organisms. Imagine them as a pair of molecular shears. These esterase enzymes start working on remifentanil as soon as it enters the body. Remifentanil's ester linkage is snipped. Remifentanil rapidly degrades into smaller, inactive bits due to snipping or hydrolysis. It's like diluting a really effective painkiller with water. The kicker is that the ester bond in remifentanil is particularly vulnerable to hydrolysis. This occurs practically instantly after the medicine is ingested. This means that the effects of remifentanil wear off very quickly. During medical operations, it is used to alleviate pain quickly before being discarded. How come other opioids, like fentanyl, don't undergo this ester hydrolysis? Their unique chemical compositions explain the difference. Fentanyl and many other opioids do not have this ester connection as remifentanil does. They display distinct chemical differences instead. These distinctions lead them to adopt different metabolic routes throughout the body. The esterase scissors don't cut them up quite as easily. As a result, their effects last longer than those of remifentanil. They remain in the system longer, reducing discomfort for a longer amount of time. Therefore, remifentanil's unusual chemistry lies at the heart of the ester hydrolysis phenomena. It's fascinating to see how such a little change in a drug's chemical structure can have such a large effect on human health. Our discussion of ester hydrolysis and why it is unique to remifentanil is now at an end.